right, great. So, okay, so we talked about, guys, if you have three fixtures in a parking lot, there are no walls, so there's no reflected lights, and we need to find the contribution of these three fixtures at three locations. So before we do anything, I want you guys to look at the graphic to understand what the graphic is. I have fixture A, fixture B, fixture C. Everybody understand what fixture A, B, and C? They are placed 1 feet apart in a parking lot, no walls, no reflected lights. Nick, because you're going to ask what's coefficient of utilization, Chad? No reflected light. It's in a parking lot, no walls, so they're A, B, and C. And so they're placed 1 feet apart, and I need to find the foot candle calculation at every point listed here. Point 1, which is immediately under A, point 2, which is immediately under B, and point 3, which is immediately under C. But I want to find the foot candle contribution from every fixture at every point listed here. Cool? The height is 10, and the figure, you have to have the isometric curve for these guys, the data, and they're all coming from Fig 5.3, page 50. So otherwise you can't solve this problem because you need the lumens. So if you guys go to page 50, and let's use this example that we have abused it almost. Okay, so that's basically the and that will show you the horizontal illumination at various points of the luminaire. Okay, any question guys about what we are given? Guard factor. Guard factor. Since they are outside, we have a guard factor that will absorb some of the lights. Ashley, when you put them outside, you have a guard on the fixture to protect it, and that guard threw up some of the light. Some of the light is not going to be going there. So guard factor is 0.88. The height is 10. The fixture is that we're looking at is high pressure sodium, 70 watt, and I'm reading from page 50. And I need to find the contribution at different heights. Before we go, I want you guys to look at the geometry. Look at everybody knows that Q1, which is angle 1 here, is equivalent to Q1 here. Can you guys see that? The red Q is equivalent to the green Q because of symmetry, right? Symmetrical between the two triangles, two symmetrical triangles. Cool. So I don't have to repeat myself. Every time, guys, when we do a test like this, always look at the symmetrical, because the symmetrical will cut down half or 1/3 of your calculation. So this Q1 and Q1 here are equal. So then, can you guys see where Q2 is coming? Q2 is actually between C and 1. That's what we need to calculate. Okay, so let's go ahead and let me get my email off so it doesn't bother me. Any question, guys, about what's given and what we need to do? We need to find the calculation at every point. Any question? Ashley, does it make sense? Where we're going to do the contribution. Do you guys have that figure with you? Yes, sir.
That's a cosine of Q.
Yes. The formula that we use, thank you. The formula that we use is the CP, which is candela power, multiplied by the cosine of the angle raised to the power 3, divided by the height. This is my height. The height raised to the power 2, and there's a derating factor, which is the guard factor. You can add a maintenance factor to a guard factor, which is 0.88. So this is the formula that we're going to use. So what I did, guys, when I copied it for you, I have number 1, this is at point 1. So from fixture B at point 2. So we're looking right here, 1 from fixture B at point 1. From fixture B at point 1. So then we're going to find from fixture C at point 1 and from fixture A at point 1. So that's 1. Then we're going to go, point B is identical to point 1, right? And then point 2, guys, you're going to find from B to 2 and from C to 2 and from A to 2 is identical to from B to 1. So you're going to see how the identical angles are. I don't know if you guys can see, this angle right here is actually also Q1, right? From here to here, that Q1. So there is no need for me to do a calculation. And also, if you draw an angle here, this angle, what do you guys think this angle by symmetry is? Q1. Thank you. So there's a lot of Q1. So I don't need to find, if I find from B to 1, from B to 3 is identical. Why? Because the distance is the same, and the height is the same, and the fixture is the same. So we're going to take advantage of all the symmetry. And when I give you guys a test, I give you all of them are identical. Otherwise, if I'm going to mess around with you, I will change this one to 25 and this one to 20. More calculation. Okay, any question about the given before we go into applying the formula? All right, let's go apply the formula. Take the foot candle. Before we do the foot candle, we need to find the Q, guys, the angle. So Q, the Q, so this is from point, from B at point 2, from B at point 2, right underneath it, from B at point 2. What's the angle, guys? From B at point 2, 0, right? Because we're looking at the angle with the vertical. So Q, I don't know, I'm going to call it, what are you going to call this Q here? Right underneath it. This is the nadir point. Nadir point equals 0, right? So if you take a Q of 0, if you take the cosine, so we have a Q, so cosine of a 0 is what? Is a 1, right? So that's the first thing you need to do. You find, the first thing you need to do is find the angle. Q, the nadir point right underneath it, they call it the nadir point, right underneath the fixture, is 0. Cosine 0 is 1. Done. Then plug in your, let's plug in the formula and do the calculation. So foot candle equal, the first thing is the guard, which is 0.88 times. Okay, now I need to find the foot candle, guys. I need to find the candela power at the angle 0. What's the candela power at angle 0?
949.
How much?
949.
949. The candela power at angle 0 is 949. I'm looking at the, that's why. Getting page 50. Okay, thank you. So it's 949. So everybody knows where the 949 came. Any question where the 949 came to be, guys? It's the lumens at the angle 0. Lumens at angle 0 multiplied by cosine 0 raised to the power 3, which is basically 1, divided by the height of the fixture, which is 10 to the power 2. 10 to the power 2. If you did the math on that baby, you're going to end up with something small, similar to this. 8.4 foot candle. 8.4 foot candle. Yeah.
What angle did you get on the 1?
The 1?
Yeah.
Cosine 0 is 1. 1 raised to the power?
No, what angle are we looking at?
We're looking at the angle right here. Oops. Let me use a different color so it shows it. Here.
Oh, the angle on the straight line.
The straight line.
Oh,
Right underneath it. 0.
oh.
Straight line. Good point. Right underneath it. Any question, guys, about this? Any question about this? So we found the contribution from fixture B at point 2. At point 2. Why did they start with point 2? Because point 2 has more calculation to it. Okay. Any question, guys, about this? I want to remind you, we're going to take advantage of the symmetry between all these triangles. So Q1, 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 all these are symmetrical. And Chris, if I want to look at Q2, I don't know if you guys can see, if you shoot one right in here, that will also give you Q2, symmetrical. A to 3 is the same as C to 1, right? A to 3, C to 1. Same angle. Okay. Any question about this calculation? Should I go to the next one? Next, my friend, we're good? Okay. So if you go next, the next one, we need to go from fixture A at point 2. Fixture A at point 2, Ashley. Here's fixture A at point 2. We need to find the angle. So fixture A at point 2, the angle is Q1. To find the angle, you take the tan. What's tan of Q1, guys? The opposite over the adjacent, right? Is that what the tan is? Opposite Q1, the tan of Q1 is opposite is 20 over the adjacent is 10 because this is a 10-foot. Okay, so the first thing you need to do is find Q2. In this case, Q2, my friends, to find Q2, you need to go tan Q2 equal the opposite over the adjacent, 20 over 10 equal 2, right? And then grab your calculator and find tan inverse tan 2. Inverse tan 2 equal, what is it? 63.4 degree or something like that. Yeah. 0.2 or 0.4? 0.4 degree. Yeah. Okay, everybody knows how to go inverse tan. You have to have a scientific calculator to get the inverse tan. Okay, so we found the angle. Who cares about finding the angle? Now we can go ahead and we find the foot candle. Foot candle equal 0.88. Multiply this baby by, we need 63, guys. Do we have a 63?
No, we're 65.
Okay, and I told you guys we go to the closest. So I have 65 or 75. Where do you think I should go? Or 55? 65. So I'm going to go for 65. So what is it? 7, 8, 0. I'm going to say this is approximately 65 degrees, just to give us an idea where to find the calculation for it. Go to the closest. Ashley, I told you guys to go to the closest or do interpolation if you want to. 65 multiplied by cosine 63.4 raised to the power 3. Divide everything by the height, which is 10 squared. Divide everything by the height, which is 10 squared. Cool? Everybody guys see where 780 is coming from? 780? But I continue to use the 63.4 to give us a good estimate. If you guys did the math in that one, and I hope somebody will check me here, I came up with 0.62 foot candle. Not a whole lot. 0.62. It's not expected to be a whole lot because it's coming from a different fixture. 0.62. Any question, guys? Any question about this? Now I want to remind you, the last thing you need to do is from fixture C at point 2. Can you guys see from C to 2 is the same as from A to 2, right? Symmetrical. Because of symmetrical, the calculation from A to 2 is identical to C to 2. So what do you guys expect the answer here to be? 0.62, right? 0.62. One more time. I did the contribution from B to 2. I did it, we found it, then we find it from A to 2. A to 2 and C to 2 are identical. I'm going to take you guys back into what we're looking at. From C to 2, exactly the same from A to 2 because of symmetrical triangles. And it's the same angle. Do I need to do the calculation again? Symmetrical, identical. So everybody knows what it, so I did the contribution from A to 2, from C to 2 are identical. No need to repeat the calculation. Unless Chad goes through up and put different height or different layout. Yes, sir.
We have 780, not 760.
How much?
Candela power, 780, not 760.
780?
Yep. Contabulated, which is more correct.
No, actually, it's 780. Let's just do this one. Did you? I think I used in the math. 0.780. If you do the math, I think I did it. Yep, I just wrote it wrong. I'm sorry. I did not interpolate. I would love to interpolate, but I did not.
Well, I mean, it's not that hard. Just go down to 760.
Yeah.
That's what it is.
If you want to do it, tell me, Chad, I'm going to do interpolation, and do it and do it in the test, and no question asked. You know what, the reason that
The range of angles, Michael, what's in between 55 and 65? You know, there's a bunch of degrees there. We've got 63 degrees, so it's just estimating, you know.
there's a mathematical way of doing it, though.
I'm sure there is.
There is a mathematical
But the
way. I promise you I'll go over it, but not today.
You just don't go over it.
Yeah. Okay, any question, guys, about this? So we found all the contribution at point 1, Ashley. Now I'm going to do next is find total foot candle at point 2 from A, B, and C. What do you think you're going to do with them? You're going to add them up, right? So I'm going to add the contribution at point 2 from, remind you, from A and B and C at point 2. This will be a 0.4. Oops. The first one will be 8.4 plus 0.62 plus 0.62 equal 9.64. 9.64. Did you guys come up? Everybody knows what we've done? Now we have 1 point and we got the contribution from all the fixtures to that point. Chris, can I get you guys to see one little thing? Just one little thing. Can you see that the substantial amount of light at point 2 is coming from fixture A as it should? The rest, guys, Aladipo, can you see the substantial amount of light at point 2 is coming from fixture A right above it? But the other contribution, you can almost ignore the contribution of the other fixture because they're small. And you still get a reasonable amount of value. So between 9.64 and 8.4, you almost get what? Almost 1 foot candle, the contribution of the other two. So the lion's share of the foot candle at that point is coming from the fixture right above it. That, as it should. That's why we put it there. Any questions about this? Any question? Jackson, straightforward, right? Okay, let's go to point 2. I have point 2 now. Do I need to do the calculation for point 2? Let's take you guys back to point 2. This is for at point, for calculation at point 2. We're going to do we did the calculation at point 2. Let's go to the calculation at point 1. Let's go where point 1 is located. Here's point 1. Point 1 from A to 1 and B to 1, we already did that. From A to 1 and B to 1, we already did that. So let's go. So fixture A at point 1 is what? Because it's a symmetrical. Anybody can tell me what that would be? The symmetrical is going to be 8.4. So guys, from fixture A at point 1 is symmetrical to B at point 2. Right? So if you do the calculation, prove it, be my guest. From fixture B at point 1 is symmetrical to A at point 2, right above it. So this one would get me from A at point 2, which will give me 0.62. Done deal. You guys have them written, right? Any question, guys, about this? I can't emphasize the symmetrical between all these systems. Symmetrical. Any question? Okay. So we're doing calculation. I want to remind you, we're doing calculation for point 1. Point 1. All right. Can I go? Got it, Aladipo? Because you guys have the. So no need for us to do the calculation, these two calculations. The last calculation we need to. So from A to 1 and from B to 1 already calculated because it's symmetrical. No need to mess around with them. Now from point C, from C to point 1. You guys know where C and 1 are? They're 20 feet apart. So I need to do the calculation. So for this one, the distance is 10 and 10 for a total of 20 feet, right?
40 feet, 40 feet, 20.
Thank you. 20 and 20 for a total of 40. Right there. So this was a 20 here and 20 here for a total of 40. Okay. So Q2, then we need to find Q2, right, my friends? So I'm going to find Q10, Q2 equal the opposite over the adjacent, which is 40 over 10 equal 4. Okay? And then if you guys continue with that one, if you take tan inverse Q2 equal, tan inverse 4 equal Q2. Tan inverse 4, tan inverse 4 equal 76. Anybody came up with something different? 76 degrees. This is Q2. So I found Q2 as 76 degrees. Now I can plug in the numbers. I can go ahead and plug in the numbers. So we found these. Now from here, foot candle equal 0.88 times. Now 76 Aladipo, what's the closest to 76? I'm going to say closest to this one is 75 degrees Celsius. What's Celsius, Chad? Or not temperature here? 75 degrees. These are just degrees. Okay. So from 75, what's the contribution, guys? At 75? 780. Right? At
194.
194? 194. Okay. You're right. Multiplied by cosine 76 raised to the power 3 over 10 to the power 2. If you did the math on that baby, you're going to end up with very, very small, 0.024. So actually, for all practical reasons, we could have ignored that contribution. For all practical reasons. 20 feet away, the contribution is very minimum, less than 1%, less than half percent, less than a quarter percent, almost. So it's very, very minimum, but we want you guys to do it for the exercise. Okay. Any questions about this? So the total from fixture A, fixture B, and fixture C at point 1, piece of cake, Chad. Then we take the contribution from fixture A, which was 8.4, plus the contribution fixture B, which is 0.62, plus the contribution for fixture C, which is 0.024. If you add them all up, you're going to end up with 9.04. Not a whole lot of contribution added from the other fixture. For all practical reasons, Nick, from these 0.62 and 0.024, we could have ignored them and still get close to the value. Any questions about this? That's the foot candle at point 1. Chris, my friend, at point 1. Okay? All the contribution at point 1 from A, B, and C. Now, be my guest and do the calculation again, or take advantage of symmetry. At point 1 from A, B, and C is the same, guys, as at point 3 from A, B, and C, if you look at the symmetry. So do I need to repeat my calculation again? I hope not. And then the contribution here, the only thing I want you to write is the foot candle equal 9.04. Everybody knows why 9.04? Because ABC at point 3 is identical, symmetrical, to ABC at point 1. Any question? How would the calculation be more complicated? Highly unlikely, actually. It's only if somebody's going to screw up. If the fixture height is different. Why would you do that? Why would anybody put a 30-foot poles and a 35-foot pole, or a 10 and 15. I mean, there got to be a certain application, but most of the time, guys, the height of the fixtures are the same, 10 or 30 or 25 or 20. That's one. The second thing they can screw up the calculation, the symmetry, is if you space them differently. And always base, if you can, if you're doing it by hand, especially by hand, space them symmetrical. They will get you good contribution. Okay, the last word, guys, about this one, interpolation. The reason why I don't like to do interpolation, for one reason, because we're doing it much faster, much quicker. Good morning, my friend. Much quicker, much faster. We're doing it with what? With visuals. Questions? Questions? Okay, so basically your exam will be similar, a problem similar to this, plus 20 problems from the back of the book that we have. Any question? Okay, so let me